Welcome to an exploration of the intricate world of engineering. Today, we dive into the nuanced concepts of limits, fits, and tolerances. These key terms underpin the design and manufacturing of mechanical parts, ensuring precision and efficiency in every piece produced. Imagine a world where limits don't exist. A world where the maximum and minimum dimensions of a part are not defined. The part could be any size, rendering it useless in a complex assembly. But in our world, limits do exist. For instance, picture a shaft with a nominal diameter of 10 millimeters. This shaft might have an upper limit of 10.01 millimeters and a lower limit of 9.99 millimeters. The diameter of the shaft can fluctuate within these boundaries, but never beyond. But it's not all about limits. The relationship or fit between two mating parts is equally crucial. Take a shaft and a hole. The fit between these two parts could be classified as a clearance fit, an interference fit, or a transition fit. A clearance fit, for instance, is when the shaft is smaller than the hole, leaving a gap between the two. This allows for easy assembly and disassembly, but may result in some movement between the parts. An interference fit, on the other hand, is when the shaft is larger than the hole, causing an overlap. This fit requires force or heat for assembly and disassembly, but offers a rigid and secure connection. Lastly, a transition fit is when the shaft and the hole have overlapping limits. Depending on the actual dimensions of the parts, this fit could result in either a clearance or an interference. This offers a degree of alignment and stability, with a measure of variation in assembly and disassembly. And then we have tolerances, the permissible variation in the dimensions of a part. Consider a shaft with a nominal diameter of 10 millimeters and a tolerance of plus or minus 0.01 millimeters. This means its upper limit is 10.01 millimeters, and its lower limit is 9.99 millimeters. Tolerances are pivotal in ensuring the quality of a part, affecting its fit, stress levels, wear and tear, ease of manufacturing and inspection, and ultimately, its cost. The choice of limits, fits, and tolerances is influenced by a multitude of factors, including the part's function, the materials used, manufacturing processes, environmental conditions, and the industry standards followed. These standards could be set by organizations like ISO, ANSI, DIN, or GIs. In this exploration, the ISO system serves as our guide to understanding the application of limits, fits, and tolerances to different types of parts. We also delve into common applications and challenges related to these concepts in engineering practice. So, there you have it, a journey through the world of limits, fits, and tolerances. These concepts, while seemingly simple, play an integral role in the manufacturing and engineering industries, ensuring precision, quality, and functionality in every part produced. Make sure to stay tuned for more insightful content and remember to subscribe for more engineering explorations. Until next time, keep engineering.